In this video, you're going to learn how to solve quadratic equations using 5 different methods. We're going to go through 11 problems. I'm going to do 6 where I'm going to show you the different techniques, and then I'll have 5 that you can practice on your own at the end, and we'll go through those as well, and you can kind of decide which is going to be the best method to use in each particular example. So let's dive in and talk about these 5 different methods and how to apply them. So the first one we're going to talk about is how to solve using this graphing method. So to do the graphing method, you want to get everything on one side of the equal sign, set it equal to 0, and then what we're going to do is we're going to graph this left side of the equation, y equals x squared plus 4x minus 5. Now, you probably remember how to graph. You're going to want to find the vertex, and we can do that by using this formula, negative b over 2a, or the opposite of b over 2a. So this is going to be a is 1, b is 4, and c is negative 5. So the opposite of b is going to be negative 4 over 2 times a, which is 1. So negative 4 over 2 is negative 2. So what that tells us is that at negative 2, that's our axis of symmetry. That's the line that divides the parabola in half. But if we take the negative 2 and we put it back in for x, we can solve for the y-coordinate of the vertex. So that comes out to 4 minus 8 minus 5. So that's negative 4 minus 5, which is negative 9. So you can see here that our vertex is going to be at a negative 2, negative 9. So let's plot that. 1, 2, 3, 4, 5, 6, 7, 8, 9. Right there is our vertex. Now what I would do is I'd make a table and I'd pick some points on either side of the vertex since it's symmetric. So negative 4, and 0, negative 5, and 1. Now let's go ahead and put some of these values in. So if we put negative 1 in, let's see, so negative 1 would be 1 plus negative 4, which is negative 3, minus 5 is negative 8. So if we know this is negative 8, negative 3 is also negative 8 since it's the same on both sides. So that's going to put us here and here. If we put 0 in, that's going to give us 0 plus 0 minus 5, which is negative 5. So these are both going to be negative 5. So 2, 3, 4, negative 5, right about here. And then if we put, let's say, 1 in, that's going to give us 1 plus 4 is 5, minus 5 is 0. So that means that both of these are going to be 0. So at 1, we're at 0, and over here at negative 5, we're at 0. So if we graph this, there's our parabola, and we're interested in where the parabola is equal to 0, where the y value is equal to 0. Those are the x-intercepts, or the zeros, and you can see that occurs at negative 5 and at 1. So those are going to be your solutions. Now, the only time that I would really use this graphing method is if they said, solve this equation, and here's the graph. And then all you have to do is look at the graph and say, oh, it's crossing the x-axis at negative 5 and 1. Those are my solutions, okay? But I wouldn't take all the time to graph it because it's time consuming, as well as the fact that it doesn't always cross at integer values. So you might, like if it crossed somewhere in between these two values, it would be kind of hard to estimate or find that exact answer. You'd just be estimating. So graphing method's not my favorite unless the graph is given. Let's take a look at some of the other examples. Okay, for example number 2 now, let's talk about the factoring method. Now the factoring method I generally use when it's easy to factor, and that usually occurs when the a value, this coefficient in front of the x squared term, is just equal to 1. Then all you have to do is say, can I find two numbers that multiply to c but add to b? And then if you can find that, it's going to be factored easily. So you can say, in this case, what two numbers multiply to 15 but add to negative 8? Well, in this case, you can see that's going to be negative 5 times negative 3 is 15, and negative 5 plus negative 3 is negative 8, and we can go right into our factored form. Then once we have it factored, we just have to set each factor, each group equal to 0, and solve. So here, if I add 5 to both sides, x is equal to 5. If I add 3 to both sides, x is equal to 3, and those are our solutions. So again, factoring is when it's easy to factor, usually when the a is equal to 1. Now for number 3 and 4, let's talk about this square root method. So you use the square root method when you have a perfect square. Now, like in this first example, you can see, oh, we just have an x squared term, but no x to the first term. So you can get this by itself and take the square root of both sides. That's the square root method. Same thing here, you have a binomial squared. That's a perfect square. We just have to get that by itself and take the square root of both sides. So let's look at these examples here. Now for number 3, I'm trying to get this x squared by itself. So instead of multiplying by 5/4, let me multiply by the reciprocal 4/5 to both sides of the equation. This way these cancel or undo each other and we're left with x squared. And here 75 is like 75 over 1. So we can do a little bit of cross reducing. 5 goes in here once, 5 goes in here 15 times. 15 times 4 is 60, divided by 1 is 60. Now all I have to do is take the square root of both sides. Remember, when you take the square root of both sides, you get 2 answers, plus or minus, positive or negative. And then square root of 60, we can write that as 4 times 15. The reason I did that is because 4 is a perfect square. That's just going to be 2. 15 is not a perfect square, and we can't pull out or divide out any perfect squares from 15. So this would be like an exact answer, plus or minus 2 squared root of 15. Now you could also do this on the calculator and get a decimal approximation, but that depends on what your teacher is looking for. Now for number 4, see this one, we have this binomial squared, so we're just going to take the square root of both sides like that. The square and the square root cancel. Square root of 16 is going to be plus or minus 4. Now in this particular problem, sometimes it's good to split this up into 2 equations. What I mean is you could write one where it's equal to positive 4 and one where it's equal to negative 4, and then solve them separately. So if I subtract 3 from both sides, you can see we get x is equal to 1 or x is equal to negative 7, and those would be your 2 solutions for this problem. Let's take a look at another example. Okay, for number 5 now, let's talk about this completing the square method. Now I use the completing the square method when the a value, this coefficient in front of the x squared, is equal to 1, but the b value, the number in front of the x, is an even number, like 2, 4, 6, 8, like that. That's going to be when it's easiest to use completing the square. Now if the a value is not 1, you could, let's say it was 2, you could divide everything by 2, or if it was 3, you could divide everything by 3. But if you get fractions, that might not be your best bet because it's going to be a little bit more challenging to use the completing the square method. So in this case, to complete the square, what you want to do is you want to get the constant to the other side. So I'm just going to subtract 2 from both sides just to get that constant kind of out of the way. Then to complete the square, you take half of the b value and you square it. So sometimes I do this work off to the side. I say negative 10 divided by 2 and I square it. So that's negative 5. Negative 5 squared is 25. If you add 25 to the left side of the equation, you have to add it to the right to keep it balanced. Now what we can do is we can factor this left side, and it's going to be a perfect square, like a binomial squared. It's always going to be half of this b value, so x minus 5, the quantity squared. You can check your work by writing x minus 5 times x minus 5 and foiling. You'll get back the original. If this was plus 10x, this would be plus 5. And that equals 23. And then now all we have to do is use what we did when we did the square root method. Because this is a perfect square, you can just take the square root of both sides. So that's going to give us plus or minus the square root of 23, x minus 5. Now what you can do here to get x by itself is add 5, but make sure you add the 5 in front of or to the left of the plus or minus sign. So this is going to be x is equal to 5 plus or minus the square root of 23, and that's an exact answer. Now, you could do this on your calculator, 5 plus square root of 23, get a decimal approximation. 5 minus the square root of 23, get a decimal approximation, but this is exact. So again, completing the square method, I would only tend to use this if a is equal to 1 and the b is an even number. Okay, now number 6, this is kind of like a catch-all one, the quadratic formula. And you can use this in any scenario. It doesn't matter what A, B, C are, whether they're even or A is not 1 or A is 1. It basically, when I use a quadratic formula, it's like it's going to be difficult to factor. I don't have a graph. I don't have perfect squares. A is not equal to 1 or B is not an even number. It's difficult to factor. Basically, when it's a real kind of a mess, so to speak, that's when I would use a quadratic formula. That's going to be your best bet. But you can use it in any one of the basically at any point or any time you can use a quadratic formula. So in this case, A is 3, B is negative 2, C is negative 4. Make sure you capture whether it's positive or negative, and then you're going to want to memorize that quadratic formula there. So let's go ahead and do it. We've got x is equal to the opposite of b, so the opposite of negative 2 is positive 2, plus or minus b squared, so negative 2 squared is 4, minus 4 times a, which is 3, times c, which is negative 4, all divided by 2 times a. 2 times 3 is 6. Okay, so let's simplify a little bit here. And this, sometimes students make little mistakes with these signs, so be careful. You've got a negative 4 times 3 is negative 12. A negative 12 times negative 4 is positive 48. So we have 4 plus 48, which is 52. So this is x is equal to 2 plus or minus the square root of 52 all over 6. Now square root of 52 we can simplify into 4 times 13. And the reason I did that is because 4 is a perfect square. So the square root of 4 is just going to be 2. And then what you can do, you can reduce all these numbers by 2. Sometimes students will just do maybe this one or this one, but you want to make sure you divide everything by the same number to reduce it. You could also factor out a 2 and then reduce that like that, but I'm just going to divide everything by 2. So that's going to be 1 plus or minus 1 square root of 13, all divided by 3, and that's an exact answer using our quadratic formula. Now what we're going to do next is I'm going to give you 5 examples, and I'd like for you to try to practice these on your own. Go ahead and pause the video and decide which method you should use in each case. Now you might be able to use more than one, but just pick one. I would try to pick whatever is going to be the easiest method. And just so you know, I kind of mixed them up. I didn't put them in this particular order. Okay, so go ahead and pause the video. What do you think you would do on number 7 and number 8 and number 9? Well, let's see. So for number 7, when I look at this, I can see that the a value is 1. And is this easy to factor? Are there 2 numbers that multiply to the c value but add to the b value? Yes, there are. It looks like I could multiply negative 4 and positive 3 together. That gives you negative 12, and negative 4 plus 3 is negative 1. So that we can go right into the factored form. And once we have it factored, we can set both factors equal to 0 and solve. So if I subtract 3 from both sides, we get x equals negative 3, and if I add 4 to both sides, we get x equals 4, and those are our solutions. So this one was easily factored, so factoring method is real quick and easy. For number 8, what did you do on this one? Well, this one, you can see the a value is 1, but there's not a number that multiply, no, 2 numbers that multiply to c but add to b. So this one's not easily factored. But what I do notice is that this b value is even. So this is going to be good for completing the square. So let's go ahead and do the completing the square method by subtracting 1 to the other side, just to get it out of the way. Then we take half of this b value and square it. So half of 8 is 4, and 4 squared is 16. So we're going to add 16 to both sides of the equation. So that gives us 15. And then we can factor this. This is now a perfect square. It's going to be x plus 4, the quantity squared. Remember, it's always half of that b value. If this was minus 8x, that'd be minus 4. Now we can basically use our square root method because this is a perfect square, and we're going to take the square root of both sides. So we get plus or minus the square root of 15. Here the square and the square root cancel, so we get x plus 4. And then if I subtract 4 from both sides, we get negative 4 plus or minus the square root of 15. When you subtract that 4, make sure you put it to the left or in front of that plus or minus sign. So this was a good method for completing this square. Now for number 9, what do you think about this one? 4x squared is equal to 9. Well, this one you can see we've got a perfect square here. We've got x squared. So I would use the square root method by dividing both sides by 4. And then what we can do is we can take the square root of both sides to get x by itself. Remember, when you take the square root of both sides, you get 2 answers, plus or minus. The square root of 9 is 3, the square root of 4 is 2, so we get plus or minus 3 over 2. Let's take a look at 2 more examples. See if you can do number 10 and number 11. So for number 10, we've got 2x squared minus 3x minus 5 equals 0. What do you think would be the best method to use in this case? Well, it looks like there's a lot going on here. The a is not 1, the b is not even, and it looks like this might be a little bit tricky to factor, so I'm just going to go straight to the quadratic formula. So here you can see a is 2, b is negative 3, and c is negative 5. So plugging those values into our quadratic formula, the opposite of b would be positive 3, plus or minus b squared, negative 3 squared is 9, minus 4 times a, which is 2, times c, which is negative 5, all divided by 2 times a. 2 times 2 is 4. So if we simplify here, Let's see what we have. Negative 4 times 2 is negative 8. Negative 8 times negative 5 is 40. 9 plus 40 is 49. And we know the square root of 49 is 7. So we can see 3 plus 7 is 10 divided by 4. And 3 minus 7 is negative 4 divided by 4. So this reduces to 5 over 2, or negative 1. So those are your two solutions using the quadratic formula. This one you could actually factor, but it was a little bit more challenging to factor. Number 11, this one we're not even given an equation, but we are given a graph. So obviously we want to use the graphing method. And we can see that where is it equal to 0? That's where it crosses the x-axis, and that's going to be right here at negative 1 and positive 3. And so those would be the solutions, or your zeros, or your x-intercepts. So great job if you were able to follow all the different examples in this video. If you want more practice and you want to see more explanations and more problems, follow me over to a previous video I did on the same topic, talking about solving quadratic equations using 5 different methods, and I'll see you over in that video.